It's going. Now it's going. Okay.
Alright, so guys, that note that I passed out, we're not going to do anything with that yet, so just put it to the side. We're going to start out with a review. So, question number 1, can I have a volunteer to tell me what that is? Anybody? Yeah. Anybody? Right.
Linear?
Kind of what I was looking for was a slope-intercept form. So, can someone tell me what this B is? Anybody remember from when you guys did graphing earlier in the year?
No.
Anybody? Kind of?
The y-intercept?
Perfect, thank you, yes. The B is the y-intercept. Someone tell me what MX is.
The slope?
The slope, thank you very much, that's awesome. Alright, so now we're going to move down to number 2. Y equals 5. Can someone tell me what's special about just y equals 5?
There's no y-intercept.
Well, there is a y-intercept. Perfect, thank you. So, on the graph, if you were to graph this, you go 1, 2, 3, 4, 5, and then you draw a line right through 5. So there's no slope, it's just a straight line crossing the y-intercept at 5. Alright, so can someone explain to me how I am going to graph number 3? What can I do first? Right there in the back, yeah.
The y-intercept is 1, so you go up 1
Thank you. Alright, next step. Anybody got the next step for me? Think you got it?
I can see it.
Go for it, yeah.
Go over 2 again?
Close. The rise is 2, yes, thank you. Yep. So you go up 2, over 1, because this is really a fraction 2 over 1. So, and then you keep repeating that process, going up, draw your line on the graph. There you go. Alright, one of these questions was on your pretest that you got Friday. So it's the point 210, a solution to the following system, y equals 3x plus 4 and negative 3x plus... Wow, that's not right. Y equals 4. Woohoo! Okay, anyway, what would I start doing with this one? Yep.
Well, if you wanted to put it with y, you could put negative 3x plus 4 equals 4.
On this side?
No, on the y.
The y? Well, what I'm thinking, and you might be saying this, maybe I'm just not getting it correctly, but you want all of these to be in y equals mx plus b form. So what you would do is you add the 3x on this side, add it on this side, and you get y equals 3x plus 4. And then what you would do then is plug in 2 for your x and see if they come out to equal to 10, which is your y value, and in fact it does. So what I'm going to do next is show you guys a little cool trick on your calculators. For this day.
It will. It's crunchy though. Yeah, perfect.
Alright, so I have a sample problem on my calculator already picked out. Alright. If it works. Cool. Okay. So I'm going to be on that side, yeah. Alright. We need what? Oh boy.
Is this your camera?
No, I don't have any more money.
Alright, so what we have here in the graphing portion of the calculator, we have the equation y equals x plus 29, and then the second one is y equals 3x plus 5. So on your calculator, you have this lovely little graph button right where my finger is. You push that, it'll graph the equation for you. And then if you hit this blue second button, calculate right here, you go all the way down to intersect, go left on the curve on the blue line, and then it will switch to the next line. And then if you go to the right of where you think the graphs cross, then you guess. The third step is guess where it is, and look at that, look at your x and y. It'll tell you right where the intersection is. Which is what the intersection is what we're trying to find when we solve systems of equations. So now we're going to get to this note sheet. Should I pass out to everyone? Can you pull that out for me, please? Is this going to spaz out on me again?
It might, but if it does, just unplug the gray cord.
Okay. Well, that's not straight. Is that better?
Yep.
Okay, so
You can move the camera however you need. You might need to change the angle of the camera. It tilts.
okay, cool. So for the first blank, what I'm going to want you guys to write and follow along with me is a system of linear equations is two or more linear equations.
Is that better for you guys to see?
Yeah, so
So what we're going to be doing with in this section is you're going to get two different, instead of just the one I did up here on the board, 2x plus 1, you're going to get two different equations. You're going to graph them both at the same time, and where they cross is what your answer is going to be. So that's why you have to use two or more linear equations. The next line is a solution of system of linear equations is a coordinate point that satisfies both equations at the same time. So what this means is the intersection where the two graphs cross, that singular point is on both lines. So that's it's going to be pretty important to know. Also, there's a little side note on the bottom that you guys should pay attention to. Point of intersection, POI, is the same thing as the solution of the system. So in your guys' homework tonight, your answers are going to be the point, so written in point form. So, the next one, no solution. So some of your graphs might never cross. So that's what a no solution means. A no solution, the lines do not have a common point. Therefore, they must be parallel. And if two lines are parallel, they're never ever going to cross. So that's why it's no solution. Moving on to the last one. A system of equations has infinite many solutions when the equations are exactly the same. And this is the case because if they're exactly the same, then every single point on the first line is on every single point on the second line. So that means every single point is a solution to both equations. All right. Cool. All right, so now it's kind of scary. All right, moving on now. Okay, you can't really see this, but since you guys have your notes, then I think it'll be just fine. So in these little blanks right here for the first one, the lines intersect. So there is one solution. And since we're just doing linear equations between just lines, you're only ever going to have one solution. Now, I don't know when you get into quadratic equations. That's when you get the u's and the v's, and upside down v's, and upside down u's. And that, if you have a upside down u and then a line going this way, you can have 2 points. And then you have 2 answers. But since we're just doing linear, we're just going to focus on 1 point for now. All right, moving over to the next graph. The lines are parallel. So, referring back to the notes up top, that means there are going to be no solutions because they're never ever going to cross. And then, moving on to the last one, the lines are equal. So there are infinite many solutions.
Do you remember solving equations, folks, and when it came down, the variables canceled and it came out to a true statement? Do you remember doing those kind of equations? That's what he's talking about when he said the lines are equal. It's because they are equal is a true statement. It's infinitely many solutions. And when it came down to a not true statement, where they like 5 equals 4, that's what he's talking about. There's no solution. Okay? That's tying back to a while ago.
All right, we're going to flip the page. And because of your crazy schedule today, we're going to skip down to 1A and 1B. And then after we do those two, we're going to have like a little fun little activity. So, yeah. All right, so 1A, y equals x plus 2, y equals 2x plus 1. So kind of like we did earlier with the review question, someone tell me what I'm going to do to start this problem. We'll start with y equals x plus 2. How would I graph that? You don't know? Right here.
Wouldn't you start by placing point flying down the y-intercept for both?
Yeah, we can do that. We can do both, sure. So for the first one, what would the y-intercept be? 2? All right, so let's put a point at 0, 2. So we have a point at 0, 2. Actually, we're just going to do the first one right now. So the slope is just x. It's just x. The fraction is 1 over 1, which is 1. So you can go up 1, over 1. So from this point, we're going to go up 1, over 1. And from that point, we're going to go up 1, over 1 again. And then you always like to have your graph go on both sides of your y-intercept. So instead of going up 1, over 1, on the left, what are we going to do?
Down.
Yes. So down 1, over to the left 1. Down 1, over to the left 1. And we're going to do one more. And as best you can, draw a straight line right through all those points. And hit with little arrows, because that would go on forever. And then now we're going to move on to the second equation there. So we start at the y-intercept plus 1. But this time, what are we going to do with our slope? Somebody over here, yes.
Go up 2 over 1.
Yep, perfect. So you start here, up 1, 2, over 1. Oh, well, we've already traced our point, but let's just keep going. So we got a point there. From that one, do the same thing, up 2, over 1. And then since we got to have points on both sides of our graph, what are we going to do?
Down 2.
Yeah, perfect. So down 2, over 1. Down 2, over 1. Draw our lines right through that graph. And then who can tell me where they overlap? 1, 3, yes, thank you. So that is going to be your solution, where they intersect 1, 3. And I don't know how Mrs. Innocencio wants you guys to show your work and keep track of your answers. But what I always did when I was in school, I would write the point and then have a P to show where that point is. But then I'd go back to my lines on my graph and I'd show which line is which equation. So for our first one, which is our the first one we drew, I would put y equals x plus 2 right next to it to show the teacher that that's that line. And then on the other one, I would go y equals 2x plus 1. Let the teacher know that that's the one, that it is that one.
And be sure you write your solution as an ordered pair. Like Cassie just shared that it's 0.13. It gets written as an ordered pair with parentheses. That's the point of intersection, so that is the solution to the system. Okay?
Alright, now we're going to do one more practice on the activity. Alright, so this one is a little trickier. So for the first one, someone tell me, what's our y-intercept? -1. Alright. Put a point there. Alright. Now with this slope, we got a negative in front of it. So we're going to go down 1 from here, over 2 to the left. From that point, down 1, over 2 to the left. But then on the right side of our equation,
Is that slope negative?
yeah, the top one. Yeah. And then oh, I'm sorry. Yeah, I see what I did. I apologize.
That's all right.
Sorry, guys.
That's actually a common error that lots of us make. So if you're going to go down 1, you've taken care of that negative already, go right.
And you go over to the 2, right, because the 2's positive.
So you can either go up and left or down and right.
Yep. So, thank you for that. Down 1, over 2 to this side. Down 1, over 2 to that side. And then going up, we're actually going to go to the left this time, because it's a negative slope. So you go up 1, over 2, up 1, over 2. Draw our straight line. And because I'm just going to do it right away this time, I'm going to write my y equals negative 1/2 x minus 1 in the beginning, so I know which one I've already graphed. Going to the second one, we got y equals x minus 4. So our y-intercept is going to be negative 4. So we go down 4. And then our slope is just, again, kind of like in the first problem, just 1. But this time they're just going to be positive. So we go up 1, over 1, up 1, over 1, up 1, over 1. And then we're going to go to the left 2 point, so down 1, over 1 from our original, down 1, over 1. Then we're going to draw that line in, which is y equals x minus 4. All right, who can tell me this time what our solution is going to be in point form? Someone have it up? Yeah, right here.
Can I do this 2 over 2?
Yes, perfect. But the first number is our x value. So instead of a negative 2, which way is the x going? Is the point?
Good afternoon once again. Just another reminder, students who are in band and ride the bus home and sold items for the band fundraiser, you need to head over to the high school cafeteria at this time to pick up your goods. If you are in band and sold items but do not ride the bus, do not go at this time. You can wait until after school. Thanks.
Do you ride the bus Mercedes?
That'll be good. Yeah, okay. So the point is on the right side of our y-intercept. So perfect. Yes. All right. So then we write that in point form with our p next to it, and that's that. All right. So now what we're going to do, you're going to do this in groups. What I'm going to do is I'm going to give each one of your table groups one of these cards and one of these graphs. And let's say if I gave this group over here this card, I would have them graph these 2 equations on this graph paper. Once they do that and did what we have just done, then they're going to one of these 7 stations. 1, 2, 3, 4, 5, 6, 7. And they're going to find which graph matches their card and the one that they graphed. And let's go to this one. Let's say if whatever group has this one, once they match their graph with this graph and they see that it's correct, there's on the bottom there's a next stop. And so what your group's then going to do, then they're going to graph that one on the next one, then they're going to find that one around the room. But then once they found that one and made sure it's right, then there's another one on that one that you're going to go find. So your group in total is going to have 7 different graphs. And once you get back to your original one, then you're done. And then you can work on whatever homework there is for tomorrow. Yes, you have a question?
Is it like each group gets one paper or each person?
Yeah, each group gets one paper. And when you switch to the next graph, you got to switch writers. We don't want somebody graphing every single problem because that's just not fair and you guys aren't learning that way.
So is everybody understand you're going to work as a team, you're going to graph the pair of equations, and then find which one matches your graph. Is everybody get that?
Yes.
Sorry.
Pick someone to do the writing right now and put all group members' names. You have lots of graphs, lots of coordinate planes. In the top right-hand corner, put all group members' names, okay? So that, because you're sharing that one sheet of paper.
Do we do it on the graph or above?
Right on the graph is fine, because you've got lots of graphs to share.
Really?
No.
Oh,
I mean, yeah, it's just quick. It was early April.
Any questions, just raise your hand and I'll come down to help you out. Make sure you guys are talking.
Wow, that is a very good line.
We actually practice outside of this. Baseball? Yeah. Maybe my practice outside of basketball.
Team with you. Brad sits by you. The egg sits like that.
I should have came in at lunch.
Liv, who's missing from your table? No one. Aurora, who sits by you? Thank you. Oh my God. Easily, why would you do that?
Yeah, you did.
You didn't realize it either.
Make sure when you move on to new graph, there's always a new writer.
Wait, where are we
Turned it around already. I think they were doing it.
The one that figures that.
Correct worksheet, we never corrected our worksheet. There's 3 back there, Jamie, and there's 2 over here. Just don't get it.
Yep, that's it.
Okay, we done? Which one?
She didn't hate. I don't care.
We can't do this. Can't be in the middle of the road, can't do it.
7-inch back.
Doing something, you should. Kind of flip back.
We're just like. Wait, where's my earbag?
So just follow,
Help him so he sees what he needs to do.
My leg almost gave out.
Seventh parallel.
I not say that. My mom would kill me if she heard me say that.
Slanting parallel.
I didn't hear it either. No, we don't say that. Okay, we're cute.
I remember that.
Yeah, after I went out, I just bring it
Okay, guys, no matter where you're at, you have about 2 minutes left. So after 2 minutes, you're gonna go back to your seat.
Alright, next one is y equals x plus 3. Y equals
Wait, hold up.
y equals x plus
Hey guys, can we bring the voice down a little bit?
No, it's not wrong. It's wrong. Because you're supposed to go up 3 and then draw a straight line, and then up 6. Aurora. So make 6.
You guys got about 1 minute.
Whoa, what's that? What?
I need it. I need it for like a minute. Wait, who has it?
Oh, wait,
Alright, you guys head back to your seats for me?
what's in there?
You want to check or do you want to?
Oh, no.
We have 2 minutes left. Alright, so, can you guys try that for me? Alright, thank you. So, let's, for example, this group, you guys started out with this one?
Yeah.
So, which graph do you think it was? Seven?
Yeah.
Okay, so I just want everyone to see, they got 7, which is right, perfect. And a way that you can check your answer is once you got 2 7 on your graph, if you plug 2 into here, 2 times 3 equals 6, plus 1, you get 7. So that's your y value. If you do it for the same, the next one, in the same x value, you should get the same y value. So 2 times 2, which is 4. 4 plus 3 equals 7. Let's do one more. We have this card. All right, so we have y equals 1/2 x plus 3, and y plus 1/2 x equals 3. So which graph was this one, guys?
That was,
The one over there in the back left corner? What did you guys get for your point?
0, 3.
0, 3? All right, let's try it. So we plug in a 0 for our x. 1/2 times 0 is 0, thank you. Anything times 0 is 0. 0 plus 3, your y becomes 3. You plug in. But once you get this in a slope-intercept form, it's a negative x. Negative 1/2 x. But does a negative times 0, does that affect anything? No, it's still 0. So then you would do 0 plus 3, and you would get your y value equal 3. So that's an easy way to check your answers when you're doing graphing on your homework is when you plug in your x value, does it equal that y value that you got in your point? And then if it works for both of them, then that's your answer. If not, go back, recheck your graph, make sure you graph correctly, and that's it.